So we are asked to simplify each of the following four expressions. It says no, when we're done, we should have no common factors or negative exponents, and all of our factors that are the same should be collected into one group. So question A is a nice review of a really cool property we learned, right? If we have a negative exponent, so you can see here I've got an entire fraction being raised to a negative exponent, we discovered that this would be equivalent to 7x over 2x squared to the positive 2 power, right? So, and I can demonstrate that. I think I can demonstrate that numerically on a calculator with like a numerical example. Let me go back to the calculator. Um, Clear you. Second, quit. For example, if I have open parentheses, I'll go 2 divided by 3 to the negative second power. So this would be the same thing as 3 divided by 2 to the second power. Well, 3 squared is 9, 2 squared is 4, so this should be the same thing as 9/4. I can press enter, and then I can ask my calculator to kick that into a fraction. I'm like, oh, it is 9/4, right? And in fact, I could even do better than that. I think I can start with, I hit alpha and grab a fraction template. So let's just say that I've got any fraction. Oh, let me open parentheses. I'll have any fraction like 7 halves, and I'm going to raise that to the, I'll use -2 again so I can deal with the arithmetic, to the negative second power. Well, that's going to be 2/7 to the positive second power, right? That's going to be 2/7 squared, which would be 4 over 49. So I can just look at that and say, hey, that's 4/49. And it is, right? So that's really a nice way of getting rid of negative exponents, right? If you have a fraction raised to a negative power, you can do this. Now, this numerator denominator, I can simplify before I square. And I can see that I have a factor of x in the bottom, and I have 2 factors of x in the numerator. So I can simplify that to, I guess I'll do it right below here. I can simplify that to 7 divided by 2x, right? 2x. Because x divided by x squared is just 1 over x. So you can see if I was to write it out, there's an x over an xx, right? So this x over xx formed a giant 1, and I'm left with just a single factor of x in my denominator. Okay, so now when I square this, 7 squared is 49. Okay, 7 squared is 49. All right, 49, not with this big green pen. With this, I get 49. And in my denominator, I have 2x squared, right? 2x times 2x. 2x is 4x to the second power. 4x to the second power. And 49/4, there's neither one of those are divisible. 49 is not divisible by 2 or 4, so there's no common factors there. We're safe leaving it there. Next, on this next one, I'm going to clear this b to the negative second power by multiplying by b squared over b squared, right? So I'm introducing this giant 1. The benefit is that when I multiply b to the negative second times b to the second in my denominator, that is equal to b to the 0 power, which equals just the number 1. So in this one step, right, what happens now is now my denominator is just a to the 3rd power times 1, but it's just a to the 3rd. And my numerator is an a times b to the 4th. That almost looks like a 9. A times b to the 4th. So now the only thing that I need to do is simplify the fact that in my numerator there's an a, and in my denominator I have a, right? I have a. So I have a factor of a in the top and 3 factors of a in the bottom. That's going to leave me with a factor of 2 factors of a in my denominator. So my final answer will be b to the 4th in the numerator, and in the denominator I'm going to have just a squared. A to the 4th over a squared. Let's go to C. Okay. So for C, I have 3 groups of this 2A, right? I have 2A times 2A times 2A. So let's put this on hold for a minute. We'll come back to that. But let's think about the 2A, 2A, 2A. So I'll write it out. 2A, 2A, 2A. 2 times 2 is 4 times 2 is 8. And A is A cubed. So I've got 8A to the 3rd power. Okay? I'm going to bring down the rest of what I had, right? I had an A times a B cubed times an A squared times this thing. So if I look at it, this first thing is a factor of A, right? That's A to the first. So I've got 1 factor of A, 2 factors of A, and then 1, 2, 3 factors of A. So in total, there are 6 factors of A in my answer. My answer will have A to the 6th power. I have 3 factors of B, just the B to the 3rd, and then there's this 8 that lives in front of it. So my answer is 8B to the 3rd times A to the 6th power. These expressions are equivalent. This is much more, it's significantly simplified. All right, and then the last problem, I have A squared over A to the negative 2nd. To clear this negative exponent, I'm going to multiply by A to the 2nd, right? I specifically selected A to the 2nd, or X to the 2nd, because I know X to the negative 2nd times X to the positive 2nd is, here we go, X to the 0, which is the number 1. So in my numerator now, I have 3x to the 4th power, right? That's xx times xx. And in my denominator, I have the number 9. Both of those are divisible by 3, right? If I think about it, 3 over 9 is the same thing as 3 divided by 3 times 3. Clearly, there's a giant 1. And if I get rid of this factor of 1, I'm left with just a factor of 3 in the denominator. So my final answer will be x to the 4th power divided by 3.